This section, you guys, is the algebra of functions. What does that really mean? Well, if you think about what we do in algebra, especially early on in algebra, we learn how to add, subtract, multiply, and divide, objects, right? Not just numbers, but variable expressions. We do that a lot with. That's what you learn very early on, rather, in algebra. Well, we're going to do the same thing with functions. We're going to add, subtract, multiply, and divide functions. In this example, we're going to let f of x equal 2x plus 8 and g of x equal negative x squared plus 3x plus 5. And we're going to find the following. In part A, we're going to find f plus g of 2. Now, there's a lot going on with this notation that a lot of people don't realize. Implicitly, what we're saying is this. When you take a function f and you add it to a function g, then you get another function. Just like when you add a number to another number, you get a number as a result, right? When you add a function to a function, you get something that's also a function. It will pass the vertical line test if you graph it, in other words. Okay, then symbolically, what does f plus g of 2 really mean? F plus g of 2, so this is function notation, first of all. It's just like saying f of 2. So the input to f plus g is 2 when you see f plus g in parentheses and then 2 in parentheses. So this is not multiplication, even though it kind of looks like that. This is function notation once again. It's like saying f of 2. The input on the function f plus g, the input is 2. But what's kind of funny is what this is equivalent to looks like multiplication. It turns out that by definition, it makes sense to define f plus g of 2 as f of 2 plus g of 2. In other words, what we're saying is to find f plus g of 2, we add the output values f of 2 and g of 2. But this happens to look like one very familiar property of multiplication. What does it look like? It looks like the distributive law, but it's not, because we're not multiplying by 2 here. There's no multiplication in sight, but it looks like that, and that confuses the heck out of students. But just be aware, this is a definition, and it's function notation. It's not multiplication, and it's not distribution. Okay, so what does this break down to mean? Well, if we want to find f plus g of 2, all we have to do is find f of 2, find g of 2, and add the results. So we have to evaluate first, get what those output values are, and then they're just numbers, and we add them together. Not a big deal, right? It's the jargon, it's the symbolism that scares you. If you're math phobic, it's the symbolism that scares you. The stuff we do, once you get past the initial symbolism, the stuff we do is pretty familiar stuff oftentimes. All right, so separately, I'm just going to go ahead and find f of 2. Well, you guys are going to help me find it. What do I do to find f of 2? So here's f, right? It's 2x plus 8. So what do I replace x with? So 2 times 2 plus 8. Oh, okay, well, 2 times 2 is 4 plus 8, 12. So f of 2 is 12. Now over here, let's find g of 2. How do I find g of 2? Plug it in, plug it in. Do they still have those commercials? I don't know. Okay, the opposite of what do I get then?
Negative 4.
So I suggest we're plugging into this formula, right, to find g of 2. I suggest you replace x with a set of parentheses for each occurrence of x. And in that set of parentheses, you put whatever that input is over there on the left side. So it's 2 both times, right? Okay, do the exponent first. 2 squared is 4, but you have to take the opposite of it, right? So the opposite of 2 squared is negative 4. Plus 3 times 2 is 6 plus 5.
11.
So, well, Yeah, it might be easier to go negative 4 plus 6 first is what, 2? Plus 5 is 7. So long story short then, f plus g of 2 is 12 plus 7. It's f of 2 plus g of 2, which is 12 plus 7, or 19. Does that make sense to you? It's not bad, right? You've seen worse. Okay.